Hi everyone, so this is our next lesson. I didn't have room for the do now on the other page. So pause the video and do these two problems. These are practice AP problems. So number 5 is a really common problem. We're gonna do a bunch like that. So it says that if the limit as x approaches 2 is 7, what did the values of a and b have to be? So if we plug into the top, normally we just plug in for the left, plug in for the right. So we get 4a minus 5. And then we plug into the bottom, and we get 2a plus b. But we also know all of that has to equal 7, because this is the limit from the left has to equal the limit from the right, which then equals 7. So we're just setting those equal. So if 4a minus 5 equals 7, 4a is 12, a is 3. So then 6 plus b equals 7, so b equals 1. So the answer is C. All right, the limit from the right. All right, so if we plug in 4, let's see, what does that look like? So this is a square root. Okay, so this is really, part of this is asking, do we have a closed circle to the right of 4? From the right. Is it just 12? Since we're coming from the right, if you plug in a number a little bit to the bigger than 4, so like 4.1, 4.2, we do get an answer. If we were plugging in, if it was from the left, that would be an issue because you can't go from the left. So you are allowed to plug in. That gives this piece 0, right? 16 minus 16. So the answer is just 12. All right, so today we're going to be talking about limits at non-removable discontinuities. So remember the other day we were talking about a removable discontinuity is something like this. It has a limit, but the limit doesn't equal the function value. Today we're going to be talking about non-removable discontinuities, so things you can't get rid of. For example, you could have a jump. That's non-removable. And then the other big one that we're going to talk about is asymptotes. Right? If I have, say, 1 over x, I can't just get rid of that giant asymptote in the middle of it. All right, so here's an example with an asymptote. Now, in textbooks, they don't put arrows, but assume these are all arrows. These are not difficult, so take a guess. What would be the limit as x approaches 1 from the right? It's just positive infinity, right? We're right of 1 as we're going towards it. We're going up. Our y value, our limit is a y value. It's positive infinity. X approaches 0. Well, that's just this value right there, right? We're not doing anything crazy. Sometimes students get so wrapped up in the infinity, negative infinity answer that they forget that sometimes you just need to look for your y value. So the answer there is 1. And then negative 1 from the left. Negative 1 from the left is over here, and that's also going up to positive infinity. So then what would be an example where the answer would be negative infinity? 1 from the left, right? X approaches 1 from the left. That would be, I'm left of 1, so I'm over here and I'm going down. That would be negative infinity because the y value is negative. All right, so we have 1 over x squared. What is the limit as x approaches 0 from the right? It is infinity, right? From the right, we're going up. How about from the left? We are going up. So does the limit exist? It does because they're the same. It's infinity. So the limit can be infinity in this case. All right, how about this? Now we don't have a picture. So these are a little trickier when we don't have a picture. So when I try to plug in 5, right? The limit as x approaches 5 from the right, 1 over x minus 5. When I get 1, if I try to plug in, I get 1 over 0, right? That is not an indeterminate form. An indeterminate form is 0 over 0. 1 over 0 and 0 over 0 are two different things. 0 over 0 means do something else. One over 0 means one of three things. The answer is either going to be positive infinity, negative infinity, or does not exist. All right. I'll give you a hint. It's not. It does exist. Since it's from the right, it exists. Now here's the question. Is my answer going to be positive infinity or negative infinity? Well, think of a number just slightly to the right of 5, 5.1. If I plug in 1 over 5.1, that's a positive number. That's 1 over 0.1, right? Think of 1 over 0, 1 over 0.00001. It's a really big positive number. So the answer here is positive infinity. So anytime you're approaching, and notice that's an asymptote at x equals 5 of that graph. So these are all examples where we're approaching our asymptote. So pause the video and try number 8. We've got the limit as x approaches -1 from the left. I'm going to factor that. So x minus 5, x plus 1. So again, if I plug in -1, I get 1 over 0. So since it's 1 over 0, right, 1 over -6 times 0, so my answer is either positive or negative or does not exist. Positive infinity, sorry, negative infinity or does not exist. So I'm think of a number slightly to the left of -1. Don't go too far though. Some kids will put like -7. It's like, no, you need really close to -1, but to the left of it. So -1, -2, so like -1.1, right? So I'm going to plug in x equals -1.1 because I know my answer is going to be an infinity, but I'm not sure if it's positive or negative off the top of my head. So when I plug in, I get 1 over, so this is -1.1 minus 5, so that's a negative, and then -1.1 plus 1, that's a negative. A negative times a negative is a positive, so my answer is positive infinity. So I'm looking at the signs to check. When I plug in a number slightly to the left of -1, is my answer going to be a positive or negative? That's all I really need to know after I figure out I have 1 over 0. All right. This is why you need to know what LM looks like. That's why the basic graph. So 0 from the right. There's no algebraic way to do this. You need to know what that looks like without a calculator. Ln of x looks like that. That's 1. So as we're approaching 0 from the right, what's my y value? It's going down, down, down. Negative infinity. Tangent of pi over 2. So again, we need to know what these look like. So at pi over 2, right, so this is sine of theta over cosine theta. So sine of theta, so that's 1 over 0, right? So it is, we say undefined. But that's what a tan looks like. So that's from the right, though. And then we keep going. So what's happening from, that's from the right, that's from the left. So here's pi over 2. From the left, we're going up, so the answer is positive infinity. So these you just need to know what the graph looks like. All right, pause the video, try these on your own. All right, so now this one's a little more complicated because notice they're just asking what's happening at 3. So we need to check from the left of 3 and from the right of 3. If I try to plug in, again, I get 3 over 0. So now what's happening as x approaches 3 from the left of f of x? So left of 3 is like 2.9. So if I have 2.9 over 2.9 minus 3 squared, what is that a positive or a negative? Because the bottom is squared, it is a positive. How about if I go from the right? So 3.1. 3.1, 3.1 minus 3. That's also a positive, so the answer is positive infinity. You got to be careful. Sometimes you get things that don't actually work. You get a positive and then a negative, so it doesn't exist. It's really the fact that it's squared that it worked. All right, let's check this one. If I plug in, I get negative 10 over 0, right? Negative 10 over 0. That tells me check my left and my right. My answer is going to be infinity, negative infinity, or does not exist. So let's try from the left of f of x. So I'm going to try 6.9, negative 2 times 6.9 plus 4 over 7 minus 6.9 squared. So on the bottom, I get a positive because it's squared. On the top, I get a negative. So I get negative infinity for this one. So now let's try from the right. Is that going to be different? So 7.1, negative 2, 7.1 plus 4 over 7 minus 7.1 squared. So that's a positive and a negative. So the answer here is negative infinity. These only worked at 7 for the limit as x approaches 7 because they're squared. When they're not squared, the limit ends up not existing, which is why in the previous ones we did left and right. Okay, so here's our definition of vertical asymptotes. We didn't really have a good definition in Algebra 2. The line x equals c is a vertical asymptote. Ooh, sorry. Of the graph of the function, because I can spell really well. F, if any of the following. I spelled the wrong twice on this slide. So basically, if we take a left or a right limit towards a number and you get infinity or negative infinity, you're going to have an asymptote. So the calculus definition of a vertical asymptote, the limit as you approach a number equals infinity. Right? It's going to be that. It's going to go on forever. All right, so now let's do some more just practice AP. So do these problems on your own. Is x continuous at 0? Well, I do know that the limit, what is the limit of this as x approaches 0? We talked about that yesterday. That's 0. I'm lying, that's 1. The limit of that is 1. So what does k have to be for this to be continuous? It has to be 1 because we want the limit to equal the function value. All right, this one, we have a problem. We need a 4 on the bottom, not a 2. So I need to multiply by 2 on the bottom. If I multiply by 2 on the bottom, I got to multiply by 2 on the top. So then this is my 1. 2 times 1 is 2. So it's D. Find the limit as x approaches negative 2 if it exists. Let's see, from the left, the limit as x approaches negative 2 from the left of f of x is negative 8 plus 8, which is 0. And then the limit as x approaches negative 2 from the right is e to the 0, which is 1. Since the limit from the right and the left are not equal, the limit does not exist. Oh, this one looks like work. Oh, wait. 1 minus cosine squared of 3x, that equals sine squared of 3x. So this is sine squared of 3x all over x squared. Ooh, this one's fun. Okay, so I'm going to do it down here. So see how we have sine squared? So here's what we're going to do. We're going to break that up. It's sine of 3x times sine of 3x. And then I'm going to put each of them, we have that x squared on the bottom. But then what else do we need in this problem to take the limit as x approaches 0? We need a 3 on the bottom also. So I need a 3 here. If I put a 3 here, I need a 3 here. Put a 3 on the bottom, 3 on the top. So we have, that's our 1. So it's 3 times 1 times 3 times 1. Right, this is our, the limit of that's 1. So the answer is 9. That's fun. I like that problem. Stop judging me. Which of the following functions are continuous for all real numbers? X. So continuous for all real numbers. X to the 1/3 is continuous for all real numbers. Secant is not. And e to the negative x is continuous. So 1 and 3. Done. Secant is 1 over cosine. That has places where you're looking, basically this is saying where's the domain, all real numbers. So 1 and 3. All right, almost there. Pause the video, try these. Again, these are all in your book. All right, so what do we got here? I'm going to rewrite, I have a secant x. So this is really the limit as x approaches 0 of sine x over x, which is just 1. Just a fancy way of saying 1. Ooh. How do I do that? I get 0 over 0, but I have that minus. But we're not approaching 0. We're approaching pi over 3. I have to think about this one. I feel like the answer has to be 1. I don't have a good reason. But if we let x, because it's everything's being shifted to the right pi over 3. I feel in my heart that's the answer. I'm going to look that one up and go over it in class because that's weird. I don't know that I've done that one like that before. But it has to be 1. All right, and then let's see. This last one. What is this one? Multiply by the reciprocal, I'm guessing. If I multiply by 1 plus cosine x on the top and the bottom. So that's the limit as x approaches 0. 3 sine squared times 1 plus cosine x. And then the top is 1 minus cosine squared of x, which is sine squared. So the sines cancel. So I get 1 over 3 times 2, 1 over 6. Let's see, the limit as x approaches 3. So the top, from the left, we get ln of 3. That's from the left. 3 from the left. And then 3 from the right, we get 6, 3 ln of 3. So the limit does not exist. All right. So for this one, we need to rewrite tangent as sine over cosine. So the limit as x approaches 0, sine of 2x over 3x cosine of 2x. So I need a 2 on the bottom to go with this. So this is sine of 2x over 2x. And then that 3 cosine 2x is over here. Since I multiplied by a 2 on the bottom, I need a 2 on the top. So this is my 1. And then 2 over 3 cosine of 0. So 2/3. Let's see. Limit as x approaches 0. Ooh, that's a tricky one. I think this one is it 0 or does it not exist? It's definitely not 1 or -1. These are tricky. I should have prepped this a little bit better. It says sine as x approaches infinity just oscillates back and forth. I'm going to say it doesn't exist. I'm going to go with that. Not 100%. I have to look that one up. All right, there is your homework. Have a fabulous day.